We're going to go over now how to take a laptop apart. Now, I've taken apart many laptops, and though they differ from model to model, they seem to follow a general theme, and I'm going to go through my procedure for what I believe is the most efficient way to get the laptops apart. And this applies mainly if you have to get down to the motherboard level. The first thing I do is I pull the battery out. You don't want to have any charge in the laptop when you're working on it. Second, I'll start pulling out components one by one. Components that I can get to easily and that will be able to be removed so they're not connected to the motherboard, like the CD drive. And here I'm getting to the RAM. There's one stick in there. You just grab the two ends of the RAM holder and it'll pop up. Sometimes you have to use a device to get in there if it's too tight. And you pull the stick of RAM out. Then you have a wireless card. And wireless cards have that antenna. It's usually a black, gray, or white cord. It just pops right off. And again, the wireless card comes out just like the RAM does. Now we're going to get the hard drive out. And this laptop actually already has the hard drive taken out, but we'll take the cover off. Now what I really want to do is get the screen off, because the screen's going to be in the way. I want to remove it from the equation. To get to the screen in most laptops, you have to take this cover off, and that gives you access to both the keyboard and the screen. I call it the hinge cover plate because it covers the hinges. And the way to get that off is usually to just pry it off, unless it's held in by screws, and that's why I turn the computer over. I'm going to remove any screw that appears like it's directly under the hinge cover plate that could be fastening it on, because I've pried that hinge cover plate off in the past and sometimes it's screwed in from the bottom and it breaks. So rule number one, if you have to force anything off of these laptops, stop what you're doing. It's probably going to break. So I just play it safe and remove all the screws that could possibly be holding that hinge cover plate on. And the only way I'll be able to tell is when I go to attempt to take the hinge cover plate off. So just lining it up. I lined up how big that hinge cover plate is, and I'm just removing any screw that's directly under that. And this computer actually has a lot of them. Most computers don't have this many screws directly under the hinge cover plate. And that looks like all of them that could possibly be holding it in. So now we flip it over, open it back up again, and now we attempt to remove the hinge cover plate, knowing that any screw that could possibly be holding it in is removed. And one way to get to it is to push down the keys and pry under the keys, being careful not to damage the keys when you do that. Or if that doesn't work, look for some other entry point, like there was right under the hinge. And then what you have to do is kind of jiggle it, and it'll pop off. Now we have access to the keyboard, and it's going to take the 4 screws off that are holding the keyboard on. Now that hinge cover plate in some computers might have a ribbon cable attached to it, or might be fastened in a different way, but they're all generally about the same. It's kind of snapped in there, sometimes with and sometimes without screws holding it in. And keyboards, sometimes they have screws like they have in this one where I'm pulling them off now. And they always are attached by a wide ribbon cable that you just grab by both ends at the connector and pull it out. Now I'm disconnecting any ribbon cable I see. This is for the touchpad. Because when I take the top plate off of this computer, that ribbon cable is still going to be connected unless I remove it right now. Now I have access to the screen, and this is the LCD cable I'm pulling off now. And these 2 wires here go to the wireless card. You're going to find in a lot of laptops, the wireless antenna go through the computer to the bottom, to the wireless card, all the way up to the top of the screen. So you have to kind of fish it through the computer and pull it back. This way you could get the screen off. If we didn't pull these wires back, we wouldn't be able to remove the screen. And then we'll start removing screws from the hinges on the screen. This particular computer has 3 hinges that go straight down and hold the screen to the base. 1. And they're on pretty tight, which is a good thing. You want these screws to be tight on a computer because these are the ones that are holding the screen on. You don't want the screen to be flapping around. And then we'll pull the screws out of the other side. Now, if you'll notice what I'm doing with the screws after I'm taking them out of the computer, I'm putting them loosely in certain piles so I remember where they go. And we're going to talk more about this at the very end of this video, so don't get too hung up on wondering what screws go back into the computer and what positions. We will address that because that's definitely a big question. Now the screen should come right up after we pull out this last screw. The screen pops right out. Now our objective is to remove the top part of the case from the bottom part of the case so we get to the motherboard. So let's get that ribbon cable unattached. And this computer has a little circuit board here that needs to be removed, which we'll do now. Not all computers have this circuit board. This was where the power buttons are. I'm just going to take a screwdriver and just pop up the side a little bit and the whole plate should come right out. There we go. Now we're going to start removing screws from the top plate. Any screw that we see that appears to be holding the top part of the case to the bottom part of the case. And we're going to do our best to find every one. And we'll know if we miss one because the cases won't come apart. And now we want to turn it over and remove any other screw that appears to be holding the 2 cases together. Now, generally, in most computers, most of these case screws are going to be about the same size, so you might be able to keep them all in the same pile. And you'll see in the case study videos, some laptops have markings next to each screw hole that tells you the size of screw that goes in there, and that makes it really easy for us. This computer doesn't, so we'll have to keep track of the screws with a system. And when it looks like you have all the screws out, try to pry the 2 cases apart. I don't have long nails, but I generally like to use my fingernail and kind of go along the edge. And just find some entry point where there's already a little bit of an opening there, a gap that you can get your nail in and kind of bring it all around and try to get these 2 cases apart. Remember, don't force anything. And it looks like this is being held in by something, so let's check for screws. And yes, I forgot one screw on the top part of the case. Let's see what happens once we get that out. It's coming apart much easier now. So I'm glad that was in the video because I want you guys to know if it looks like it's not coming apart easy, there's probably a screw holding it in somewhere that you missed. Now we have access to the motherboard here. Let's put that off to the side. And we'll attempt to remove the motherboard now from the top part of the case. This big black device here is just the speakers, and that attaches with a connector to the motherboard. Now, certain screws on the motherboard are labeled, and that's what I'm pointing to now. They have letters next to them. Usually there's white arrows, or there could be letters, like on this computer, that's basically telling you what screws you need to remove to get the motherboard off. The motherboard has many screws if you look at it from the top, but you only need to take a few of them off to get the motherboard off. And it's usually marked on the motherboard by white arrows. In this case, it was marked with the letter PA. Now this little piece here is just an extension for the battery. Now we're going to remove all the screws on the motherboard marked with PA. And when it looks like we have them all, try to pull the motherboard out of the case, gently. And you'll start to feel where the pressure is coming from if there's any other screws holding it in. And what this is here is the processor and heatsink and CPU fan. It usually all comes off in one big device and snaps onto the motherboard with a cable there. And if you notice those numbers, 1, 2, 3, right next to the screw holes, that's usually an indicator, and it will be on most laptops, an indicator of what screws hold in the heatsink over the processor, so you don't tighten them all down in the wrong way. It actually is a guide. It helps you as a guide. And again, once you think you have all the screws, just slowly pull up the motherboard. And you'll start to feel it if you missed one. And this should be the last one there. And just kind of jiggle it until it starts to come loose. And pops right out. And that plastic piece I pulled out is just the holder for the PCM-CIA slot. I'm going to lay something down so there's no static electricity on the motherboard when I place it down. That's just an adapter that I pulled off there for the power jack. And let's clean it while we have it out. I always take the opportunity to clean the pieces when I get them out. And I use the paintbrushes for this. You're not going to have too many chances with these laptops where you're going to get down to motherboard level, so take advantage of it while you can and make sure you get it all clean. And since you have the fan out for the processor, blow it out with compressed air. Now let's take the bottom part of the case and clean that off as well. And now, say if you did have to do a motherboard replacement, you got to start putting everything back together again. And I sped this video up because putting it back together is almost identical to taking it apart in reverse order. Put that power adapter back on. Now we're putting the screws all back on the motherboard marked with the letters PA. Put the speakers on, attach them to the motherboard. They just fit right in there, which they usually do. And that's just a battery extender. Make sure you have all the screws on that were originally on the motherboard before you put the black cover back on. And that's twice. I just checked to make sure I had them all back on there, and I do now. So now I can put the cover back on. It'll usually snap right together. And now start putting the screws back in. Now if you notice, these are screws I took out originally because I thought they were holding the hinge cover plate on. But since they're not, I could put them back on now. And then I'll put all the screws back on the top plate, or the top part of the case. Attach the ribbon cable for the touchpad. Looks like I put the wrong side screw in there, so I'm going to take a couple out. And put them all back in. Sometimes you got to take a step back before you go forward. Happens to the best of them. Now put the rest of the screws in. Put that circuit board back in that has the power buttons on it, and make sure you attach the ribbon cables. Always attach your ribbon cables when you're putting things back, otherwise you have to take the whole laptop apart again. It's something that you just have to remember to do. You might get the whole thing back together and then realize the keyboard's not working because you forgot to attach the cable back to the motherboard. And we're just putting the screen on now. Now what I'm going to do, if you watch, is take a bigger screwdriver when I'm done tightening these up, because I want a little extra torque on these screws, because I don't want the screen to be flapping around. I want those screws to hold. So I just take a little bigger screwdriver and put a little extra torque into them before I put everything back. Attach the LCD cable, and now we're going to feed the wireless antenna back through the computer the same way it came out. We're going to close it up. Pull the wires through. Might as well throw the wireless card in now just to get those antenna out of the way. And they snap right back on the little connectors there. Nothing magical about those connectors. They're very easy. Just put the RAM in. Put some remaining screws back on the bottom of the case here. Okay, let's throw the keyboard in. Attach it to the motherboard with the ribbon connector. Attach the 4 screws to hold it on. Put the hinge cover plate back on. CD drive back in. Battery in. Hard drive cover back on. And that is pretty much how you do it. Most laptops are going to follow that pattern. And that's how I do it. Now, how do you keep track of the screws you get out of a computer? This is a big question. A lot of people are afraid about doing this when they start working on laptops. The method I used to do when I started out is I create a pattern right next to the laptop. A pattern identical to the pattern in which the screws are coming out. So if one screw is to the left of another screw, I place it on the table left of that screw. And I sped the tape up here. You'll notice that a pattern starts to form of the bottom of the case. And now I know where each screw goes when I go to put them back. Some people use containers. And they'll say, every screw I take out of the bottom case, I'm going to put in container number 1. So I know that all the screws in container number 1 are used for the bottom case. And then I'll get a second container. And this will be for maybe screws on the top part of the case, or screws holding the keyboard or the screen on. And then when you're down to motherboard level, there's more screws. So you could use another case for that. And that's one way to track what screws go where. I've seen people take plastic bags and lay them down in layers. Anything on the bottom layer goes into that bag. Keyboard layer goes in that bag. The top layer goes in that bag. The motherboard layer goes in that bag. And they layer them on top of each other so they know the order in which they go back. And I've had one listener tell me he creates a diagram of the actual laptop and draws the screw holes in the diagram. And then when he takes each screw out, he just puts it in the picture of the screw hole that he drew, which I think is a pretty clever idea. And same with the motherboard. And he does that for each layer that he has to. Well, that's pretty much all you need to know for now. If you watch the case study videos, you'll see some of these techniques to put in action, and I think then you'll be ready to do it yourself. Good luck. We're going to be doing a repair here on a Gateway laptop that's having power problems. Don't know exactly what the problem is now, but the first thing I'm going to do is test the power adapter. So let's get out the voltmeter, plug in the power adapter, set it to 20 volts. Take the black lead, which is the ground, put it on the outside of the tip on the power adapter. Take the red lead and stick it into the middle and touch the pin and see if we get up to 19 volts. And we're getting around 18. I mean, a little 18, close to 19, and that's the voltage we should be getting. So I'm just bending the wire around, making sure that there's no breaks in the wire, that if we bend it, it loses the connection. It seems like it's okay. So I'm gonna give the power adapter an okay here. So we're going to have to assume it's something on the inside of the computer, probably the power jack. When we plug the power adapter into the computer, these gateways usually have a battery light, a purple light that lights up, and there's no light there. So something's wrong. See, their lights are off. We would have seen a purple light if that was working okay. Then a purple sticker on the bottom shows that Best Buy worked on this thing, so hopefully there's still some hope for the machine. Take the battery out, try it again, just to make sure. Try to power it on. Still nothing. We're jiggling the power cord as we do this, jiggling the power adapter. Sometimes if you jiggle it, it makes a connection. Sometimes it doesn't on some computers, and that'll at least let you know that the power jack is bad. I'm constantly pressing the button as I'm jiggling around. Still no power, so let's open this thing up, take a look at the power jack, and see if there's anything wrong with it there. Now this computer is awfully dirty, and I really like to work on laptops that are clean. So I always try to clean them as I take them apart or before I take them apart. If it's so dirty, sometimes I just clean them before I even start working on them, just so I could see the screen, I could touch the keys without feeling grossed out. And what I do is I take a monitor wipe. I actually clean the screen first with the monitor wipe. Then I use that same monitor wipe and just go over the rest of the computer. Those monitor wipes are actually great for removing dirt and grime. They used to be alcohol-based. I don't know what they use now, but it's a good substance or solvent, whatever they use in there, that it does a good job of cleaning. And then if there's lots of chunks under the keyboard, I'll take a wet dry vac with the brush attachment and just brush over the keyboard, get all the chunks out from under it. You can't really see from this angle or this close how much stuff is really gunked in there, but I think there's a lot of junk under the keyboard that I'm sucking out there. Okay, nice and clean. At least we have the outside clean. Now we'll probably clean the insides as we take it apart. Now there's a plate under this computer that covers the RAM, the processor, and the wireless. No, just RAM and the processor. And we're going to take that plate off first and get those components out. We just want to start taking components out of the machine. Anytime we want to work on a motherboard, we just want to detach all components from the motherboard that we possibly can right off the bat. Because if we don't, those components might stop us from getting to the motherboard. There might be somebody screwing it in, or there might be screws hidden underneath the RAM, or the heatsink on the processor might be causing the motherboard to be stuck. So there we go. We could pull the heatsink and fan out in one shot, detach the fan from the motherboard. Let's take the RAM out. Take the hard drive out. And then take this cover off, which will expose the wireless card. And on this particular gateway, to get the keyboard off, you got to get to a screw under that particular panel. It's kind of a tricky little screw there, but I'll show it to you later. Actually, I'm taking it out right now. This is the screw that's holding the keyboard in. You would never know it. There's no markings. And this other screw is the other screw that's holding the keyboard in. Just because I've taken apart so many of these, I know to get those out first. Otherwise, the keyboard will not come off. Now I'm taking off the screws that are holding on that front, I call it the hinge cover plate. It's the plate that's right above the keyboard and right under the screen. And it basically gives you access to the keyboard and the screen. And since I'm right here, I'm just taking the two screws out of the back of the computer. Sometimes there's screws in the back of the computer holding in the hinges that keep the screen on. So let's get those out. And there's this one screw here that's holding in the DVD drive. Once we get that screw out, push on the tab, DVD drive pops out. And this drive is damaged, there's no front cover. You can actually see water damage there. That's not a good sign. So hopefully there's not major damage done to this motherboard. But always look for water damage, white spots on the board or on the hardware. Okay, I'm just taking a look at the processor there. Gonna leave the processor on for now. It's not really in the way. And I'm going to get a Phillips out, or a straight edge screwdriver, I'm sorry. And pull under the hinge there. And pop that hinge cover plate off. Now we unscrewed those screws from the bottom, so now we know that there's no screws holding it in from the bottom. So we could apply a little bit of pressure here, knowing that it will come off. And actually there was no screws holding it in, but it's always better to be safe. Swing that keyboard out. You'll see that there's two posts under that keyboard. There's actually more than two that hold that keyboard in. And we luckily took those screws out, which I showed you before. Now let's get the wireless cables out there, and then the LCD cable. Those wireless cables are the antenna that go to the top of the screen, and then they feed through to the wireless card. They're always a pain, those wireless antenna, but they try to get them up to the highest point on the laptop they can to give you better reception. And then there's a couple screws here just holding the hinges in for the screen. Oops. Oops again. Sometimes when I rush, I drop that screwdriver, so. Let's pull that screen right off. I love them when I get the screen off, then I don't have to worry about the thing. It's a bulky, unwieldy thing having that screen on, so it really allows you to work good on the laptop after that's off. Now there's a few more screws. And that's a normal size screw on this laptop. Almost all the screws are that same size, so we don't have to worry too much about where we put them. Let's just throw them all into one big pile. Okay, just check if there's any other screws holding the top plate on. One more over there. Let's detach the ribbon cable from the touchpad. There we go. Now we don't have to worry about breaking that cable when we take the top cover off of the bottom cover. And then let's hit all the remaining screws on the bottom here. One thing you might want to try if you want to speed up your repairs is to get an electric screwdriver. But I am very partial to this tiny one I have here that I've been using on laptops for 2 years now, probably. Same screwdriver. And it does the job fast enough for me. Now my screwdriver's losing a little bit of magnetic force, so I'm just take a magnet, which I believe came out of a speaker. I don't remember where I got that magnet. And scratch that screwdriver onto that magnet and recharge the magnetic force. Okay, let's just make sure we get all the screws out. We're going to attempt to lift the top cover from the bottom cover. And if there's no screws holding it in, all will come off very easy. And there is a screw that we missed. Just taking my finger now, I'm just pressing it in between the two covers there to pry off the front. It's like I'm just checking the computer for corrosion. It looks like something did spill in there with that discoloration on the top cover. Now let's just take a look here. Look under these. Always look under that sticky black plastic if you could get it off. See if there's anything that got under there, any water, moisture. You'll see white spots of corrosion if there is. I'm looking at the power jack there. Just want to determine what the problem is with this motherboard. If it's fried or is it just a power jack problem. So we're going to take the motherboard out. And there's 4 screws here that hold in this motherboard. All on the left side. So you pull out all those screws on the left side, then just lift up the left side of the motherboard. I was playing air drums there for some reason. And then, because I'm talking to my dad as I was doing this, but you don't hear the muted original footage. And you pull up the left side of the motherboard. That allows you to pull the right side up. And then there's that one cable there. You got to get off the motherboard. Pull that off. Motherboard is free. Now we're able to throw it down there and look to see what's going on with this thing. Take this opportunity to clean it up. Get the paintbrush. Gets all the dust out. Take a look under that black plastic if you suspect there's any water, moisture, or corrosion under there. Looks okay. Okay, now I'm interested in the power jack. If there's any points on the motherboard where the power jack's not making a connection or there might be a loose connection. And I believe there is. I'm going to try to get it in focus for the camera. And there's a spot right there at the end of my finger where the positive pin is coming through the motherboard and not making a strong connection to the bottom. So And these gateways are tricky because there's also a point at the top, and a bad USB port on this one actually, but there's a point at the top of the power jack 2 that needs to be resoldered. And as you can see, the USB port's bad too, so the USB port's damaged. We don't want that to short out. That could cause a power problem as well, so we're going to pull off that USB port. Not even going to try to repair it. It's really loose, and there's definitely damage to the plastic inside the USB port. And they're a little too specialized to do repairs on, so that baby's going to come off. Three of the 4 connections on that USB port were already torn apart, so we just got to get that one last one off, and then we'll be okay. He's got a couple other USB ports he could use, and he can always use a USB hub. Just taking the old toothbrush there, again a non-used one if possible, and just making sure there's everything's clean off the motherboard in that spot. There's no short circuit. Nothing was scratched or damaged. And I got the soldering iron out and a little file. And what I'm going to do is scratch a spot on the surface of the motherboard where I'm going to attach some solder and run a wire to the power jack. Basically, I'm going to bypass the original connection the power jack is making with the motherboard and instead replace it with a wire. And again, I use a wire because wire has flexibility, and these power jacks get bumped around a lot. And if you have a brittle connection, it's very likely that brittle connection is going to break if somebody impacts that power jack or somebody trips over the power cord while it's plugged in. So by using a wire, we're going to bypass the original circuitry and use our own method here, which will allow flexibility. And I'm taking a little piece of red wire, stripping off the ends, as you can see there, and then I'm going to attach some solder to each end of that wire. I'm going to solder it to the motherboard and connect it to the power jack. Now, in this particular gateway, we have to do this on the bottom and top of the motherboard because there's 2 points of connection. Now, you're going to see here this little spot that I filed out once it comes in focus. It's a little tiny spot right above where it says D1 towards the top of that board there. And I picked that spot because if you look directly to the right of that spot, that is where the power jack, the pin for the power jack, comes through the motherboard. So we know that that's the positive connection on the motherboard. And you can see a little bit where that positive pin is loose, and that's why I'm going to create a little divot right next to that positive pin. I'm going to use a wire, and I'm going to wire the wire directly to the back of the power jack. And that's going to replace the existing technology that's in there, which I think is faulty. This little device I just pulled out that's holding the wire is called helping hands. You should definitely have one of those for your shop. And we're going to pull out the solder here, and we're going to solder some solder to each end of that wire. Now, the soldering iron has been plugged in for a while, so it's hot. And we're going to take the soldering iron here and just melt a little bit of solder on each end of that wire. This is the technique I like to do. Like I said, I'm not a soldering professional, but this is what works for me. I like to coat each connection that I'm going to work with some solder, and then afterwards, after I get all the connections set up, I just attach 2 connections together, melt the solder together, and it makes a good solid connection. Now I'm taking some solder and I'm putting it on the motherboard, right on that spot that I filed out. And I'll show a close-up to the camera once I'm done this. Now, you don't want the exposed connections at the end of that wire to be too long, otherwise they might short circuit with something else on the motherboard. You want to keep them short. And you can't really see exactly what I'm doing here, but I'll show a close-up to the camera. I'm just soldering that little red wire to the spot on the motherboard while I filed out, you know, a spot where I could solder. And I'm just trying to be exact here. I like to be precise, and I want to make sure that that wire is not short-circuiting with anything else. And I like to grab it. You see what I did there? I'm going to keep this in the film. It's not quite a blooper. I always test. After I make a solder connection, I yank it with my pliers and make sure that the solder connection is strong. Because if it's not, and that connection wasn't, the customer will be back. So I always do the plier test at the end and just make sure the solder connection is strong. So now I'm going to resolder the connection and see if we can make a stronger bond. Again, I know you can't see my hands in the way, but I'll show you the finished product as soon as I get it soldered on. And this is what we're going for. Once that gets clear, I'm going to freeze frame it here. Now I want you to take a look here at the placement of the wire and what I did exactly. I soldered the part on the right, the solder point on the right. That's soldered to the post. That's actually soldered to the post that's coming through the motherboard from the DC jack. And it's soldered right to the end of that post. Then the wire wraps around, and then the solder point on the left-hand side solders to a point that I filed down on the motherboard. Now this basically creates just a connection from the post to a spot on the motherboard where the post should be connecting to. I hope that makes sense. What I'm doing is creating flexibility in that power jack. So see that center pin? That center pin actually bends all the way around through the motherboard and onto one of the solder points that I created. Now I'm going to take the pliers and just test the strength of the connection again. I'm not going to yank too hard, but reasonably tough just to make sure that it makes a strong connection. And it looks okay, so we're going to leave that soldering the way it is. That's done on the bottom. Now these are a little tricky because that power jack, the tip, which basically that tip turns into a post as it comes out of the back of the power jack, that post connects to 2 points on the motherboard. The point that I just soldered to and another point on the top of the motherboard. So there's two, and this is kind of rare, there's 2 points of contact that this post makes on the motherboard. One on the top and one on the bottom. So bottom we just handled. The top, again, we're going to file a little space on the motherboard where that post should be connecting to. We're going to put a little drop of solder on there once we get that filed down so the solder will stick. And then we're going to repeat the process. We're going to take a piece of wire, run it from the back of the power jack, which is the post, to the top part of the motherboard, to the spot I just filed down. I'm going to freeze frame it again here once this gets in view and show you exactly what I did. Now I want you to take a look at this close-up. This arrow is pointing to the post that's coming out the back of the power jack. That's your positive connector. That's the same thing that's coming out this side of the power jack, which is the tip in the middle of that jack. That tip goes and comes out the back of the jack as a post and attaches to this spot on the motherboard. You'll see the little drop of solder I created right here, which is on the same contact point that would be touching, that post would be touching. Now as you'll see, I'm going to be creating a connection from the post to that solder point I just created using a wire. So I'm basically doing the same purpose, the same function as the original power jack did, except I'm using a wire again, just to give it a little flexibility, but it's touching the motherboard in the same spot that the post would be, except we're using a wire. Hope that makes sense again, like I said, and we'll see how it turns out. Now I'm going to take the file again here, and this time I'm going to scuff up the back post of the power jack, which is the center pin. Comes out the back of the power jack. It's now becomes a post that goes into the motherboard. I'm going to attach our wire from this post to that solder point I created, but I need to scuff up and scratch up that post so the solder will stick, and that's what I'm doing with this file here. Just take the toothbrush and brush away any little metal particles. I'm going to take a little bit of solder. I'm going to drop it right on that back post. This could get a little tricky. That's why it's good to have a nice thin tip on the soldering iron. Definitely don't use a soldering gun for this kind of thing. Want something very fine. This is only 15-watt soldering iron. And this is the drop of solder I put on the back post of the power jack. Now we're going to cut a little piece of wire. We're going to attach it to the back post, and we're going to attach it to that solder point. Again, I'm using my little pliers here to strip the wire. Probably better use of wire cutters to do this, but I'm getting pretty good at doing it this way. The only danger of doing it that way for stripping the wires, you could actually cut the actual wire that you're trying to strip, so you don't want to do that. And again, I'm using my technique of just tinning the sides, the edges of these wires. Put a little solder on each point. You don't want to use too long of a wire, because remember, you have to stick this back into a confined area that may not have the space to fit a large wire. So that's why I use short wires to do this. Okay, I'm going to use the pliers to hold this in place. I'm going to try to zoom in and give you guys a better view here. Let's take the wire, put it in place. I guess it's not really that good of a view, but you'll see the finished product. And touch the wire to that solder point we created on the back of the post. Make sure that that's pretty solid. Pull it with some pliers there and make sure it's a good strong connection. I'm going to bend it so it fits right, it touches right at the other solder point on the motherboard. Okay, the end was a little too long, so I just cut a little bit off. You don't want too much metal showing on the end of these wires, because then it has a chance of short circuiting. And I'm just going to take a little bit of solder. It's tough to get a good view here without my hands in the way. Sorry about that, guys, but I'll show you the finished product and you'll get the idea. And that's all it took. Just a little touch of the soldering iron. Let's pull it and see if it's secure. Right now it's going from the post to that solder point we created. And I think we got a winner. And this is what we accomplished. You will see that the wire we just installed there goes from the back post of the power jack and connects to that point we put right on the motherboard, that other solder point. It's basically acting, the wire is basically acting as the post would be, but again, I used it for flexibility. I love using the wires for flexibility because now the customer can be a little more reckless with the power jack and not worry about the brittle solder points breaking because they're both connected with wires now. You got flex. Just want to test it again with the pliers, make sure it's in there well. And we're good to go. Time to put some stuff away, which I'm going to speed up for you guys real quick here. Then we're going to put the rest of the computer back together. I'm going to take the CPU heatsink and CPU fan here. You see that broken metal? That's actually how it was removed from the processor. The processor has some metal on it as well. And we're going to have to get that off and probably put some thermal grease on the processor and make a better connection. See, I'm scraping off the metal that is broken. So a lot of times on laptops, the manufacturer likes to use that thin sheet of aluminum or whatever it is to create a connection. But when it rips apart, the seal between the processor and the heatsink is not that great, so we're going to have to do it the good old-fashioned way with thermal grease. You want to get that processor removed of all the gook on there and make it nice and shiny. And then be careful that there's no residue of the paper. If you're using a paper towel like I am, make sure there's no residue of a paper towel. It might burn up. So once I'm sure I get the residue off, it's a little piece of Scotch-Brite I'm using. Just don't use that. You don't want to push too hard with that. And you can on the heatsink, but not on the processor itself. In fact, it's not a real good thing to use, but it might give you a little bit clean surface to work with. This gets to be kind of a pain. It's real gummy. When you get under that sheet of aluminum, there's a gummy residue that you have to get off. So just do the best you can. And then once we get a nice clean spot on the heatsink there, we'll reattach it and put a little drop of thermal grease and we'll be okay. In fact, I'm using a real fine grade sandpaper here. Just getting off that stingy residue, which I will speed up because it might take me a while to do this. It actually took me a lot longer than I expected, so we're going to go to the next step here, and then we'll get that CPU heatsink and fan back on. We're going to test the connections we made using our voltmeter. We're going to set it for continuity, touch it to certain points on the circuit that we just created there, and see if, just make sure that there's no short circuit. I'm just touching a ground point, and then those two wires that we put on the motherboard, they're both on the positive side. They're positive points on the motherboard. So if we touch a ground point to one of those points of that red wire we just installed and you hear a beep when you're testing for continuity, then you know, because it should not be touching any ground points, those wires we installed. There should be no contact with ground points. Just take our paintbrush and clean up as much of the bottom case as you can since you got it open. We're going to take the motherboard now. We're going to place it back into its spot. And we're going to see if it fits now that we added those wires. Those wires might be causing a problem where it won't fit now. So I'm just going to try to size it up and make sure that it fits. And I'm just looking to see if when I put the motherboard back, is it gonna create any short circuit with any of the points of the bottom case? Is our red wire gonna be touching any points of that case that we don't want it to touch? Because remember, those wires weren't there before, so it's like an extra protrusion. You want to make sure that it fits okay and there's no connections made that you don't want to be made between the case and the wires that we installed. And I think we're going to be okay. Throw the motherboard in there. Again, if it doesn't sit flush, find out why. And in this case, it's not sitting flush because that wire was under there, which is the speaker wire. Now I'm going to speed up the video here. Again, this computer gets put together the same way it came apart. Use the proper screws and the proper holes there. Get it all back together. Clean it up, little bits and pieces where you can. Put the wireless card in there. We're going to put that screen back on. Screw the screen down, and then we're going to feed that wireless antenna through. And put it back in the little slot it goes in. Same thing with the LCD cable. Okay, that's in pretty solid. Attach the wireless antenna. Hard drive goes in there. And I'm going to slow the footage down as I install the heatsink on the CPU. Again, get the stickiness off of that CPU. I'm using Scotch-Brite, but just use it very, very gently if you're using Scotch-Brite. Clean it off with the paintbrush. Make sure there's a good connection. I'm going to pull out the thermal grease here. I use Arctic Silver, but it's actually the ceramic version. So it's not quite silver, but the company's Arctic Silver. And I put a little dab on there. And I like to take a piece of Scotch tape, put it on my fingers long ways, and use it as a little steamroller to level out all the thermal grease, and it's the way you keep your fingers clean. I just don't trust when I just put a little glob of thermal grease on there, it's going to distribute itself evenly, so I like to distribute it a little bit. And now take your nice new clean heatsink, which we hope is clean enough. Sometimes the best way to get that stickiness off is with your fingers. And that's the best we're going to get. So remember to attach the CPU fan. It's vitally urgent. Your computer will overheat. You don't want to cause damage to that processor. And it's a little hairy in there. That's why it might have been a good idea to do this before we put everything back together. But I think we'll be all right. There it goes. And that slides right in there. The fan does. And the heatsink sits right on top of the processor. Make sure it's all lined up. And then I like to screw these back in a crisscross fashion like you're putting on a tire. Distribute the pressure evenly on the processor. And these plates, this is the last plate I got to put on. This covers the fan and the heatsink. They get dusty. They get dirty. Clean them up since you have them out. Like I said, always try to give your laptop back to the customer in a better condition and a cleaner condition than when you got it. Cleaner is the key word. I even brush off the bottom of that keyboard. Get it all nice and clean. You don't want little particles and residue flitting around on the motherboard, so. Okay, going to reattach that cable. Make sure it's in far enough, the way it's supposed to be. Lock it down. Make sure it's all lined up straight. Then mount the keyboard back. Usually snaps in under the plate there and then push down at the top. And I know that this particular keyboard screws in two spots. One right next to the CPU fan and the other one where the wireless card goes. Two little silver screws, very tricky. You would not think that they hold the keyboard in, but that's what I learned. Then we're going to mount this plate back on, and then we're almost done. Yes, Best Buy worked on this. You can tell by their lovely purple stickers. Chances are they didn't open it up. Otherwise, they may have charged this customer more than this computer's worth. Sorry, Best Buy, but your prices are real high. Make sure all those screws are tight, but don't over-tighten them. Never over-tighten any of these laptop screws. Just snugly fit them in there, and that should be fine. They usually have some kind of, adhesive or glue on the screw itself. That's what that blue and red color is on those screws. You'll see them are coated in blue and red. It's to kind of lock the screw in. And get all those screws in. I'm unscrewing it now for some reason. I forgot something. What did I forget? I think I just remembered, but if you guys were observant, you would know. And the missing thing is, yes, the RAM. And I shouldn't have put that one on top first. It's impossible to put that bottom one in second. So... okay, we're going to mount the RAM back in. Put this cover back on. Then the only thing we should have left is the hinge cover plate, the plate covering the wireless adapter. Throw the battery back in, and I think we're in business. Get the wireless cover back on there. Dust it off first. Those covers get real dusty. You'd be surprised how much dust comes off of them. If the dust is too thick, I don't use the paintbrush because I don't want to get the paintbrush too messed up. I just use a wet dry vac with the brush attachment. Okay, let's put this cover back on, the hinge plate cover. Or the hinge cover plate. Sorry. Now on this laptop, I believe there's 2 screws holding that plate in from the back once we get it on there. They go right over the hinge covers. Just snap these in. Sometimes they take a little maneuvering, but they will eventually go in, and they need to lay flush. They need to lay exactly how it was before you took it off. And you'll know where it is because there won't be any lumps in it. Let's get these 2 screws on that hold those hinge covers on. It's another thing you want to be careful of. You don't want to go prying that hinge cover plate off knowing that there's screws holding it in from the back because you're going to break it. So always check for those screws holding it in from the back. Gateways are famous for having them. Maybe Acers. Old HPs have them. Not too many other models have them that I know of. Now, before we plug anything in, I always like, if we do a major power jack repair, I always like to test to see if there's any short circuits before I plug anything in. I don't want to fry anything. So I'm going to touch the center pin with the red connector, and I'm going to touch a ground point with the black lead here. That's actually the other way around. It does not matter if you're doing testing continuity. The black plate is actually going to touch the middle pin. And there was no short circuit, meaning there was no beep. If we heard a beep, we'd know we'd be in trouble. Now we're going to take the power adapter and we're going to plug it in and test this thing out. And we're getting nothing. Why are we getting nothing? Time to diagnose now. Let's test the power adapter. And we're getting 20 volts or 19 volts. You couldn't see it, but the power adapter appears to be working. So let's plug the battery in and see what's going on. I'm pretty confident we did the repair okay on the power jacks, so there's got to be something else going on here. Let's see if it charges the battery. We got the power adapter in there. We're going to jiggle the power adapter. See if that makes any difference. Still not powering on. Now here's a little bit of a revelation. I skipped forward a little bit. With the power adapter in there, we got the battery light charging. When we move it the slightest bit, it goes off. Once we jiggle it and let it sit, it goes back on. Computer power's on. Everything seems to be fine. So I'm going to tell you exactly what happened. What's wrong with the power jack is the inside tip of the power jack is very worn. The tip is bad, and the hole, which is on the inside of the power adapter, just became too big through all the use and damage and whatnot. And it's so big now that it's not making a connection when we plug it into the power jacks. The power jack's okay. It's just a loose power adapter now. So what we're going to do is replace the tip on the power adapter. So as you can see here, I cut off the tip of the power adapter, the existing tip, and I already stripped out the wires. We have one that's bare and one shielded with white shielding there. The white shielding one is the positive, the unshielded one's negative. This is a Radio Shack adapter plug, size N, which fits the gateway. We're going to mount it just like that. First thing we want to do, because I always forget to do this, is put some heat shrink tubing over the wire. I use a real thick one to cover the adapter plug, and then I use a thinner one under there to actually shield the wires, as you'll see shortly. Cut a decent size for that. I'm going to pull out the helping hands here, which will hold the wires for me while I do some soldering. The thick heat shrink tubing goes over first. And what I'm going to do now is sand down the posts on this adapter plug. See, the adapter plugs are meant to be plugged into a different adapter, not for wires to be soldered onto the bare pins there. But I found it makes a good repair on a power adapter. You could buy the Radio Shack adapter that it plugs into and then just solder the wires together, but I found the wires in that adapter that this adapter plug plugs into are a little too thin. So I like to go right from the power adapter wires right into the adapter plug. It's not pretty all the time, but it'll work. And you can see I scuffed up the pins there. We're going to put it in the helping hands. We're going to drop some solder on there. I always seem to get this a little out of frame, don't I? And there we have it. Solder is dropped on there securely because we scuffed it. The solder's not going to go anywhere. It's not going to break off. And what I'm going to do now is drop some solder on the ends of these wires. I call it tinning. Coat those wires in solder. And then when you're ready, we just touch those two wires to the adapter plug, heat them up, and solder should melt together on both ends. Now these wires are copper already. We don't have to sand the wires down. The solder is going to melt right into the copper. And there's a little too much exposed on one end. I'm going to cut it a little short. There might be some stray wires hanging off the edge. Just make sure everything's nice and clean. You don't want any short circuit here. And this is the product we're going to get. Camera doesn't like to focus unless I put my hand as a background, so there you have it. Now we need a little bit of a thinner wire to go under the wide heat shrink tubing. And you'll see how this works after we get everything on there. Well, we found a good piece of heat shrink tubing that'll fit over the inside wires there. Cut it to a reasonable size. Slip it on before you do any soldering to the adapter plug, otherwise it will not fit. Okay, we're going to get out the voltmeter here. And we're going to just find out which pin is positive and which pin is negative on the adapter plug. Because on the power adapter, that one with the white shielding is positive and the one that's bare is negative. That's your ground. So we just need to make sure they get matched up properly. And we went ahead and soldered those wires now to the adapter plug. Just finishing that up. And I want to hold it in front of the camera and show you exactly what we did. And this is our product at this point. It's very important that those two wires are not touching, or any frayed part of the wire is touching the other part of the wire. It will create a direct short circuit, and we don't want that. Let's do a little cleaning up here. And do a little cleaning up. It's a smart thing to do when you're done working with your tools and materials, put them back in the same spot you got them in. Don't just keep a big pile. Keep your space clean. You can get more done that way. And what we're going to do is take some electrical tape here, and we're going to wind it around those wires that we just soldered, just to make sure that they stay separated and they're insulated. And I'll show you what I'm doing as soon as we get that back in the frame. We got the electrical tape around the two wires, and then we pushed up the heat shrink tubing over those two wires. The smaller heat shrink tubing, and then we take the thicker heat shrink tubing and we put it over the adapter plug. Now we're going to take our voltmeter before we do anything, and before we seal up the heat shrink tubing, and test the power adapter. Make sure that we're getting the proper voltage through it. And it goes right to about 19 volts, which is what we want, so we know our connections are okay. Now, because I don't have a heat gun or a lighter, I'm actually going to use the barrel of my soldering iron to melt the heat shrink tubing. Not the most optimum thing to do in the world, but it's workable in a bind, and it gives you a nice even, shrinking of the tubing, which is what we want. So once we get the inner part melted, we do the same thing to the outer part. Try not to keep the soldering iron on the heat shrink tubing at one place one time. For too long, it'll burn, and it won't smell real good either. I'm going to speed this up for you guys. Okay, that took a little while, but we're getting close, and this is going to be our finished product. Nicely shrunken. 2 layers of heat shrink tubing with the electrical tape on the inside. That came out pretty good. That's one of my better jobs, I must say. And those things are soldered direct to those posts. They're not going to go anywhere. It's a pretty secure connection. Now, what I'm about to do next might seem a little crazy. I'm actually going to cut that whole tip off of this power adapter. In between the footage here, I tested that power adapter again, and I found out the power brick itself was actually bad, not putting out the proper voltage. So since we already installed a tip, got all the heat shrink tubing done, we're just going to install this tip on another power adapter. Now this other power adapter actually has a bad tip itself, so we're going to take the good tip that we just created and solder it directly onto this new power adapter. And what we do with this is, we cut the wire, then we separate the ground from the positive. Get that old power adapter out of the way. Throw that in the trash. Okay. We're actually going to plug this in now and test the voltage. Make sure you do not touch the 2 wires together, positive and negative, while you're doing this. Got our voltmeter out. We have our exposed wires there, not touching each other. We're going to take the black to the ground, red to the positive, which is the white. Check the meter. We're getting 19 volts. We're going to unplug that power adapter. We don't want any voltage running to this while we're working on it. I did that once. It wasn't fun. Caused a rather large spark. And now I'm going to strip the other end. Solder these 2 pieces together. We'll be golden. Again, it's smart to use a wire cutter in that situation, but if you don't have one laying around, you could use a regular pair of cutters there, as long as you don't cut the wire. Okay, once you get that exposed, twist it so no fray wires are hanging out. Okay, we're going to use the helping hands here, and we're going to tin the ends of these wires. Now, the camera didn't quite catch it, but what happened was I tinned the sides of all the exposed wires. Now I'm going to throw some heat shrink tubing over it. Cut it to the right size. Now we're going to solder the 2 ends together. And because the camera's not picking it up, I will show you the finished product. Okay, there's the cable sitting right there with the heat shrink tubing over it. Now we're going to test it out in this machine and make sure everything works. Now we plug the AC adapter in. Pull out the voltmeter and do one last check just to make sure there's no short circuit and we're getting the right voltage. And we're okay. No beeps, and we were getting 19 volts. or 18.5, somewhere around there. Plug the power adapter in. Since there's no battery, there's not going to be any charging light, but there is the power light. And this computer is definitely working now. Took a little bit of work, but we finally got it done. That was a power jack and a power adapter fix. Let's throw the battery in there and see if we get the battery charging light when we plug it in. It's that purple light on the front of these gateways. And it should appear right about there in a second, and there we have it. So that's a pretty thorough repair on a power jack and power adapter. And there you have it.